Hello again, ROS developers, and welcome to this ROS Project special on AI. If you want to learn anything about ROS, this is your channel. So you can learn about navigation, about drones, about autonomous cars, everything ROS related, you can find it here with videos of around 5 minutes to get some very concrete aspect of ROS or basic concepts, to courses of around 30 minutes or 45 minutes. So you can get loads of knowledge about ROS in our channel. I'm Miguel Ángel Rodríguez, and today we are going to continue on our project of making a cube, a robotic cube, learn how to walk with OpenAI. But before anything else, please remember to visit Robotic Night Academy. Robotic Night Academy is an online academy to learn any topic about ROS without any installation. So you can learn about ROS basics, you can learn about what we are talking about here, that, for example, OpenAI 101, about TensorFlow, these kind of topics. So if there's some aspect that you would like to practice more, or you didn't quite grasp, take a look at Robotic Night Academy. And without further ado, let's get started. So what we're going to use is, like always, we're going to use ROS DS, ROS Development Studio, and I have it already here opened. So what we're going to do is open my project that is Moving Cube Tutorials. I'm going to open it. While it opens, I'm going to just remind you that all the code that we do in these tutorials, I'm going to upload it to this Git, that it's public, you can download it when you want, and you basically will have all the code. Yeah, remember that we have one for the AI, and we have another one for the moving cubes, so for the description, for the physical simulation. Okay. And let's close all this. No, I don't want to. And yeah, so let's get started. So first thing is we're going to launch our simulation, which is here, if you remember. I highly recommend you that you pull any changes. So every time that you work on this, pull the simulation, because sometimes I do some minor tweaks and some changes to make that simulation work better, basically. So that way you'll have the newest version. Okay, we have our cube, tiny cute cube here, with one disk in the roll axis. Okay. So what do we have? So let's have a look in our nice IDE. So one of the things that it's very important for concept is, as I mentioned in the previous videos, is that you have the simulation in the simulation workspace and you have the other code in the Catkin workspace. That way we divide what is the simulation and what is the code that it's not simulation related. Okay, you can do it anywhere you want, but that way we are trying to standardize and make everyone do more or less something that it's coherent, and you can share your project with other people much easily because they'll understand the structure. So we're going to go directly here. And basically what we have is the Git with all the code. And what I'm going to do is we are going to create our own package to make this work. Okay, so let's go. So in the last video, we ended up making more or less the cube move in a way. That part is already done, so we know that it works. We know that we can move it around. So now we're going to do the OpenAI, so make it learn basically. So we go to Catkin workspace source and we go here and we do catkin create package, my moving cube, I think we called it moving cube package. We're going to call it exactly the same, but with my, like always. Then ROS by, it depends on this. And for the moment, it's enough. So let's create a package. There we have it. So now we have our nice my, and we don't have anything. So the first thing we are going to do is do a scripts folder. So let's do it, scripts. And once we have it, we're going to create already the other folders because we'll need it launch and config. Yeah, so in the launch file, in the launch directory, we put the launch files, and in the config, we're going to put all the configuration files for the training. Yeah, we're going to talk about them in a minute, but that's the use. And we don't need source, so we'll delete it. Yep, I want to delete it. Okay, perfect. Now, next step, we're going to create our OpenAI environment for this nice cube. Okay, so OpenAI. For OpenAI, you need to create an environment. This is, like we talked about in the previous video, it's a way of creating a controller, a gamepad that the learning or the training algorithm can use without knowing really how the robot works or how to move the robot. Only by instructions, by actions we call it, we move the robot. So first thing is we're going to let's do this, start training, scripts, and we're going to copy paste, and we're going to talk about this. I'm going to name it, no, that we'll leave it like that. So this is basically the code. I'm not going to type it because I think it's more interesting that I explain all the stuff, and that way you get a grasp faster of this. So first things first, what's this? So this is the script that we're going to launch to make it learn. Okay, and for this we can use any AI algorithm that we want. That's the good part of OpenAI. That is algorithm agnostic, let's say. So in this case, we're going to use QLearn. So the first thing we do here in the imports is we import Gym, we import NumPy because we use it all the time for some random functions. Then we're going to import QLearn. There are many implementations of QLearn. We're going to use, in our case, this implementation, which was made by Victor Mayoral from Robotics. So he's the author of this tiny script of QLearn. And basically we are going to use this, and then more Gym. Let's say this is OpenAI Gym wrappers, and some ROS by, of course, because we're going to use ROS for this, and ROS package to get access to the packages and have some functionality for that. And then we are doing this import all way moving cube environment. What's this exactly? Well, the functionality of this, we're going to talk about it in around when we finish talking about this script, but basically this one is the one that has the OpenAI Gym environment of the cube defined. Okay, so let's go. So first things first, you create a ROS by init node, and we're going to create this Gym. So we are going to call it differently that way. So let's say my old moving cube, for example, and then we're going to Gym environment done. Okay, and here we're defining a path where we're going to store all the output logs of the training. This is very important to see how the reward evolves around time. Then we define these last time steps, nothing important here. Then we're importing the learning parameters. So this is the time to get our config and have a look at it. So what's this? Well, here we have our namespace, which is moving cube, and here we have all the training parameters. This config files allows you to, having as many as you want, this allows you to test very fast different configurations for the learning, and that way you can optimize the speed of the learning and the efficiency and the end result. Basically that it learns faster and better. So here we were importing these parameters for the parent server that we will load. We'll see in a minute. Basically we are getting the parameters, setting them the alpha, gamma and epsilon for the qlearn in this case, and the epsilon discount, which is basically what we are doing here is stating that at the start of the learning of the Q learning algorithm, we are going to experiment a lot. Okay? 1 means we experiment all the time, and 0.9 is that we experiment a lot. And we are going to degrade it a long time. So when we've done like 100 steps, we will be experimenting less and less and less. Because supposedly we have stabilized the qlearn matrix, and that this way we reinforce the paths that work and we lower the values and the use of the ones that don't. But I mean, this depends on each problem, and you have to experiment with those values. Yeah. For now, we're going to talk about this. This is the running step, which we've set here. Okay. And then we are setting up the qlearn object and the initial epsilon. Yeah. Which initial epsilon is here, 0.9, and will be degraded along the time. You see, there's an if here that it will degrade, it will multiply by epsilon discount, which is 0.999. Okay, this means that it will degrade very slowly, relatively slowly, because we also do steps very fast. So, what's this? Well, it's a for inside a for. Okay, this for is for the episodes, so we want to do the training for a number of episodes. So we'll do, these are the number of episodes, so we'll do in this case 500 number of episodes. As I said, you can change it. Then we are going to initialize the accumulated reward, which is at the end of each episode, how well the training has gone, how well the robot has performed. Yeah, and then this is really important. So as we talk here, the done means that the episode is done or not, and then the lowering of the epsilon each time that we do it. Okay. Around each episode. So each episode we will experiment less and less and less. Okay, so this is one of the key aspects. So here we reset. Environment reset. We don't know how the environment is resetted. We don't care, because someone else has done it. Someone else has created this environment, which we've called my old moving cube, and it just works. Okay, so when we ask to reset, it resets the environment, the simulation or the real robot. It doesn't care. Then it returns an observations, which is basically the state, the sensory state in which the robot is. And that way we know that the robot has fallen, it's detecting an obstacle, it has the joints in a certain position. And here we are converting it to string, because this state is the one that we input into the QLearn algorithm. Yeah, it's like the tags. Each state is a tag, and let's say, for example, in our example, the robot can be in a certain orientation. So let's say 0, 0, 0 means that he's exactly here in this orientation, and for example 0 in the speed, so the tag would be 0, 0, 0, 0. So 0, 0, 0, 0, 0. So okay, so the tag in this case would be 4 zeros. Yeah, 3 for the orientation, roll, pitch and yaw, and 1 for the speed. And this would more or less tell us how the cube is situated in space as far as the learning is concerned, okay? Because of course we don't know exactly if it's here or here or here or here, but for our purpose maybe we don't care, okay? Yeah. So here we start the number of steps, so the steps. So we divide our episodes in steps. How many steps? Well, in this case 1000 maximum. We can do less because it can fall over and put the done to true, but in theory maximum 1000, and then we restart the episode again. We reset the episode. And what are we going to do here? Well, basically we feeding the state. So hey, my robot is here in this configuration. Okay, perfect. Let's say, for example, I don't know, it's like that, and it moved here, okay, and the wheel is spinning. So what do I have to do? So you ask it to the QLearn matrix, and the matrix says, well, in my experience, you have to move the wheel forwards, I don't know, 80 radians per second, I don't know. Then he says, okay, let's do this action. So we do this step. So we execute this action and see what's the result. Yeah? And this would be the step. We feed in the action and into the environment executes everything, calculates all the rewards. So says, okay, the result has been good or has been bad or very bad, means that done, it's done because it has fallen over. Like that, I don't know, it's, let's say, like that means that the robot has fallen and we have to reset again. Okay, so episode finished. Yeah. Okay, so it gives all this. We don't care how this is done, just like that. Then, next. Well, the next step is, once we have this, we add it to the reward, to know the final reward, the accumulated reward. We convert this observation into a tag, okay? Yeah, like the string, what we talked about. We print just to see if it works or not, or we don't need to do this, but it's debugging, and I think at the start, when you start, it's good to see if things are coherent, at least. And then we say, okay, it's done, perfect. Oh, sorry, it's not done, then next state. And so the state gets, this is the next state, or it's done, hey, it's done. So we have to break this for the steps and finish. And then what we do? Well, basically we format the time and so on, and we give like a resume, like a conclusion, all the data that we have of the episode, number of episodes, the alpha, the gamma that we had, the epsilon, the reward, and the time that we spent doing this episode. Yeah, and this is also stored in these the logs. Okay, this is how we are going to teach. How are we going to teach the robot through OpenAI using QLearn? You could use DeepQ, you could use like very deep TensorFlow, I don't know, any kind of learning algorithm, you can use it. And it doesn't matter the robot that you're using. This would be more or less the same. Yeah? At least, yeah, the structure. And that's quite it for today. In the description of the video, you will find a complete course on Robotic Night Academy about OpenAI 101 to get the feeling of this. Did you like the video? If you liked it, please leave a thumbs up and consider subscribing. We publish videos every day. And share any opinions or comments that you want in the comment section. And that's it. Thank you and see you in the next video. Hasta la próxima.